All right, welcome again to Good Choices, my catchphrase, because I believe this is a good choice. There is such thing as exercising, which I'm not doing. But yeah, this is the next best thing. You got to get the money coming in, got to have a good career. That's important. So as long as you're not being a workaholic, or even if you are, as long as it's just short term and you can get your savings up and live a better life as a result, it's a good choice. So I'm gonna make the choice here to continue on with this lesson. These are the explorational exercises, and I'm gonna close out dot two. All right, first explorational exercise. Once more, using the my password file from the previous exercises, devise a bash command that will select one individual from the main office to win a raffle contest. Use the sed command to print out to only print out the lines for the main office, and then a cut command sequence to retrieve the first name of each user from those lines. Next, you will want to randomly sort these names and only print out the top name from the list. Okay, so last video I spent about a half an hour doing that. Was it worth it? Yes. Okay, so moving on. Okay. Okay, there we go. Okay, I just want to make this easier to read here. So, okay, so the first thing we're going to do is we're going to select wow, okay. That's kind of tricky. So what we're going to do is use the so we want to select an individual from this file to win a what? Yeah. So that's gonna be there's like an extra part to this file. Is this? I'm not sure if that file is correct. I'm gonna double check it. Nope, it's got. So I guess the winner can be sis, or bin, or demon. So maybe we need to do something about that. We need to make sure that we only get human users. So I guess what we could do is match on this field, and anyone in the 100,000 user group is eligible to win. But I mean, if we did that, then Carol couldn't win. So I don't know if that would be fair to Carol. Um, so yeah, we're gonna need to have it so that Carol is eligible as well. But all of these we don't need want. So what can we match on? So we can match on the user group. We can match on the user IDs. You know what? Let's do that. Let's match on the user IDs so we can see all of these users have one digit for the user IDs. This has 3 digits, but yeah, they're very unique from one another. Here, they're quite similar. 1000, 1, 2. They're just sequential from 1000. So what we can do is match on this. We can even match all the way on this, but we won't need to. This will be enough of a match. So let's do that using SED. So if I remember correct, and I most certainly do not, dash n, of course, so that it prints things out correctly. Then we're going to look for this, and then we're going to print out what we find, and we're going to do that on the my password file. And there we go. We've only got the human users. We're not shortchanging Carol. Um, what does she stand to win? I forget. Oh, this is just kind of a tangent. I don't need to determine this. Man, why is it so hard to navigate this thing? All right, here we go. So it's a raffle contest. It doesn't say what to win. But anyways, you want all the people to be involved in it, and we've got it. Next, we're gonna pull names from the raffle. So, um, so let's pull. So let's further narrow this down using the. Can we just pipe it into SED? Well, let's pipe it into cut. And then we're gonna cut it based on uh, the character. So C, I believe it was C for character, and we're gonna cut it based on the that character. Then we're gonna go with the field 1, 2, 3, 4, 5, the fifth field. So we get the first and last name, and then we're gonna cut it again. Now that we have that, we're gonna cut it based on the comma, and then we're going to take the first field. So that should give us the names. Only one type of list may be specified. So it looks like maybe the dash C is not correct. Let's take a look at the help. So dash C is characters. Yeah, that was wrong. So we got to do delimitator. Kind of like the Python split. Dash C would be like you're matching for this character. So it's dash D. Like we're not matching for the character. We're in fact not including the character in our results. We're yeah. So now we got all the names. Perfect. So now what we got to do is randomly sort these names and only print out the top name of the list. So let's see if SED has that function in it. So it's going to be something like sort, isn't it? I could do it in Python. I do not see anything about sorting. So I mean, the thing is, SCD is a scripting language, so it's like, I wish I could get more. Let's go to the SCD homepage. Hopefully, we get more information about the actual syntax of the programming language. Let's see anything about sorting. Here's the. Okay, so maybe there's a sort. Man, SCD is really difficult. Man, how do you like tell what the syntax of the. All right, let's ask the AI. What is the programming syntax of SCD? Okay. So how do you write a SED script. Without this AI, it'd be so ridiculous. Oh, so here's an example of an SED. So the swap here, and then the G. I don't know what the G stands for. Usually it's P for print. Okay, so we're going to break down this script. So what are all the options? And why is that a G? Perform globally on each line. Not just the first line. So would you do like a dash P as well as the dash G? Or slash, I mean? Oh no, you do it in two different... Then you delete the lines. Huh. What about dash N? What does dash N do? Suppress the automatic printing of pattern space? That is very bizarre. Okay, well anyways, like the syntax is like that. It's just what are all the options I have at my disposal when writing a SED script? Okay, so here we go, dash N, dash E script. But the thing is, it's not... Okay, additionally, within the script itself, you have a wide range of commands, pattern matching techniques, and modifiers that allow you to perform various text manipulation options. These include substitution, S, deletion, D, printing, P, insertion, appending, branching, and looping. So... Okay, some of the commonly you can also use man. So how can I know the wide range of commands, pattern matching techniques, and modifiers for SED directly from the CLI, from help available at the bash prompt? The man page and dash help seems not to explain dash E inputs such as find me P. Alright, so to get information about the wide range of commands, pattern matching techniques, and modifiers available instead directly from the help of the bash prompt, you can use the set command with the dash help. While the dash help option doesn't provide an exhaustive... It does offer a brief overview of the most commonly used. Okay, where does it do that? Man, this is frustrating. This is really frustrating and annoying me. How am I expected to know how to use SED if it's not written down anywhere? Do I just need to magically know exactly what is contained and what sorts of options are available? Do I need to be the person who created it myself? How am I expected to know this thing when there's nothing written anywhere about how to actually use it? Okay. Oh, no, I'm talking... Sorry, no, I meant said. Answer for said. Okay. So yeah, they're just gonna tell you the same. You're just telling me. You're just telling me to use the same resources that I've tried to use but have failed me because they haven't been verbose enough and left too much information missing. Can I go somewhere like online where I can see a complete explanation for how to use SED? Okay, so I think I went here. Yeah, I think I went there as well. Here's an SED tutorial. Here's another one. Okay. Well, I don't see it there. Oh, maybe this is good. Okay, yeah, this isn't bad. But see, like, you can do SEDG and you can double space a file. It doesn't say that anywhere. How am I supposed to know that? But yeah, this looks like it's it. I'll include this in the like the oh, doobly doo is such a good word for it. The doobly doo of the video. The description. This looks like it's pretty good as well. I'll include that in there. So let's see if there's anything about sorting. Okay, we do have a match. So, oh, you know what we could do? I don't know. Sort. Ah, here we go. So we can sort paragraphs of a file alphabetically. Paragraphs are separated by blank lines. Uses -V or any unique character will do. Oh my god, look at this nightmare. See, this is what like inspires Pythonic. It's like this is not Pythonic. Like this is why there exists Python. Ugh. What a disaster. I give up. I quit. I am looking at the answer. I got it so far as to get I remembered this without any assistance, the delimitator in the field, but I don't know how to pick one randomly. Maybe there's a sort function. I think maybe that's it. Is we can do pipe sort. Yeah, there we go. So there's some sort of, I can use an extra application, the sort. So what we can do is say sort random -r, random sort. Boom, got it. -R. Boom, there we go. So Grace wins, Carol wins, Emma wins. Grace wins again. She's lucky as heck. Dave Edwards wins. Grace is the luckiest person in the world. She should probably get a lottery ticket. Frank wins. Who's the unluckiest person on here? John? Yeah, John's got nothing. Sorry, John. Grace. Oh, there we go. Okay, he wins. But Grace is definitely going to win this thing. Oh, she hasn't won in a while. All right, John's coming back, rallying back. Okay, but I did it. So the other thing we need to do now is I think cut this down again. So we want to I think there's another cut command to just take the first line. So, or we could do head, the head command, and then dash n, and we're gonna print the first line. Pipe head dash n equals 1. Oh, 1. There we go. I did it. Wow, I kind of impressed myself. I did it in this way. I didn't use just said, and I didn't use just a cut command. I used cut twice, and I used sort, and then I used head. But you know what? It works. That's the thing that really matters in the end, in my opinion. Working code is better than any other kind of code. In fact, any other kind of code besides working code is totally irrelevant, in my opinion. I don't care what the code looks like as long as it works. To an extent, there is a point where, well, honestly, there isn't. If the code works, like, it works. It doesn't. Nothing else matters. Like, if it doesn't work, it doesn't work. Like, there's a difference between it working and it not working. And like, okay, you can think of, okay, this code does what's intended, but it's so ugly that nobody else knows what's going on. It can't be changed later. Well, guess what? That code doesn't work. Like, does it do the thing you expect it to do? Yes, but is that code that works? Probably not. So, this is using 1, 2, 3, 4, 5 pipes. 1, 2, 3, 4. But like in my example, in my opinion, this is the perfect example of code that works. Like, this does not have to be anything but this to accomplish what we're going for here. Anything else is just wasting time and resources. All right, so first explore how the parameter -r manipulates the output of the sort command. Repeat this command a couple times on your machine. Note that you need to enclose main office within single quotes, so SED will handle it as a single string. Oh, that's it. So okay, so they did a different matching than I did. They did a match on main office. Oh, you know what? That's because they read the full question and I did not. So I don't think Carol's eligible to win because she works from home like a king. And sorry. All right. So yep, Carol. Oh no, Carol is part of the main office. Okay. So yeah, they're all from the main office. So okay, I didn't necessarily do this wrong. But I did fail to read the question. But it's not that tricky. It's just they can now match on the delimitator. So they're matching on the colon. They're taking the fifth field. 0, 1, 2, 3, 4, 5, and then they're matching on this, and they're taking the first field. Perfect. And then, so here's the solution to the problem. It's basically the exact same thing I had, except I didn't match on the main office. I chose a different matching criteria, but it does just so happen to include everyone in the main office. All right. So how many people work in finance, engineering, and sales? Consider exploring the UN unique command. Okay, so we'll explore that. So UNIQ help. So -u print only unique lines. So I think I can do this. So let's see here. So I'm going to print out that my password file. So the question is, how many people work in finance, engineering, and sales. How many people? Okay, finance, engineering, and sales. I mean, there's no one that doesn't work in finance, engineering, or sales. But to determine how many people, that's a good question. I don't know. Okay, we've got a space. So to include that, we need the quotes. I don't know if they have to be single quotes. I'm not sure about that. But got the same thing. So here's all the people in the, oops, yep, D, then the fifth, or the fourth, I think. 1, 2, 3, 4. Nope, the fifth. And then cut dash D. We go dash F1. Okay, so here's all the people again. So we want to know how many people work. I guess they're saying in respectively, like how many people work in finance, how many people work in engineering, and how many people work in sales, I think is what they're trying. So what is the okay, so we can prefix lines by the number of occurrences. So we can pipe this file to unique dash C. Okay, that's not how you spell. That is how you spell unique, but it's not how you call the utility named UNIQ. Okay, so now we've got the instances. Okay, yeah, so this is how you do this. So for each of these lines, there's only one instance of this whole thing, but we want to know how many people work in each of these respective departments. So we can do a match for each of them. We can do a match on finance. All right, and then all we care about is that the number of people in finance. So we can do UNIQ dash C. Oh, actually we have to cut it. So pipe UNIQ dash C. Okay, well let's get a different field here. So we get field 4. Okay, there we go. So sorry, no, did that all wrong. So we're gonna cut on the delimiter here. Yep, this one here. So we don't want field 4, we want field 2. Perfect. I win. I won $1 million. Now I'm gonna spend it on I don't know, a diamond. What is it? 5 golden rings. Okay. So 4 for finance, 1 for engineering, 2 for sales. Is that correct? Yep. Looks right to me. Yeah, and here's my answer. Let's see how close I came to what they were doing. So keep building on top of what you learned in the previous exercises. Try the following. Yep, so I learned how to match on that. The dash for print. I learned how to cut based on delimiters. It looks like, yeah, you can just cut it based on the delimiter there. Notice how we do not care about the first delimiter, the colon. We just want the second field when we split the lines by the comma characters. Yeah, so you can narrow it down all you want. So if you split it like this, then you can save yourself one call of the cut command, which is probably a good thing. Okay, so there we go. And then unique dash C, we did the help and we saw that the C parameter tells unique to count the occurrences of the equal lines. So the unique parameter will only print the unique lines, not the repeating lines. And the parameter dash C tells unique to count the occurrences of the equal lines. There is a caveat here. Unique will only consider adjacent lines. When this is not the case, you will have to use the sort command. So what is an adjacent line? Let's ask the AI. What is an adjacent line? So an adjacent line is... An adjacent line refers to a line that immediately follows or precedes another line in a given sequence or arrangement. In the context of the unique command, UNIQ, it means that duplicate lines must be consecutive or appear one after another in order for UNIQ unique to identify and remove them. For example, consider the following input. So are these adjacent lines or not? I don't know. In this case, the adjacent lines are apple and apple. Adjacent. What? That's really weird. As well as banana and banana. I do not understand that. When using UNIQ on this input, it will correctly remove the adjacent lines, duplicate lines, resulting in the following. However, the lines were not adjacent. It would not identify them. What? This is really weird. So I guess they're no longer adjacent. In this case, since the duplicate lines apple and banana are not consecutive or adjacent, UNIQ would treat them as separate unique lines. That's weird. The output would be the same as the input. Man, that is weird. What is it? So how is useful at all? I would think that this problem of adjacent lines would show up all the time. This seems like a critical flaw that would render REN useless for most situations. So I raise a valid point. Interesting. The behavior of UNIQ being limited to adjacent lines can indeed be a limitation in certain scenarios where duplicate lines are not necessarily consecutive. This limitation may restrict the usefulness of unique in some cases. However, it's worth noting that unique still has merits and can be quite useful in situations where the input data does consist of multiple adjacent lines. What is an adjacent line again? Many text files and data streams do have adjacent duplicates, especially when generated by certain commands or programs. In such cases, unique simplifies the process of filtering out duplicates and providing a clean output. Similarly, as mentioned earlier, unique can be combined with other commands such as sort to overcome the limitation of adjacent lines by sorting the output. Oh, okay. Oh, that makes sense. Okay, so if you just sort them, like the lines are all going to be adjacent. Like it doesn't matter that much because you just sort it first and then they're all adjacent and then it's fine. Okay, so that's not that big of a deal. Yeah, that seemed like a game breaking thing to me, but it's like sorting is not a big deal. Like let's sort this file beforehand so we can do, and then we just need another, and then we do sort. There we go. We got the same results, but if we do cat my password file pipe sort, we should have the first line is in alphabetical order, so any lines that are duplicates will be adjacent. It's not a big deal at all. All right, so next one is number 3. So I will take a break and be right back. All right, I am back. Let's try to finish this up just in this one part. So next is now you, oops. All right, so now you want to prepare a CSV, comma, separated values file so you can easily import from the my password file in the previous example, the file names.csv into LibreOffice, the open source Linux version of Microsoft Office. The file contents will have the following format. First name, last name, position. So Carol Smith in finance. Tip, use the... Oh, no, stop. Is this the answer? Oh, no, yeah, I don't want the answer yet. Okay, so tip, use the sed, cut, and paste commands to achieve the desired results. Note that the comma will be the delimiter for this file. So I guess I need to create a delimiter somewhere. Okay. So I can do that. First thing I want to do is the sed and then -n, and then match it on let's match it on main office. Okay, and then I'll print that out for the file in question, my text file. Oops, why did it not print out? Was there no match? Did I spell office right? Do I have that file? What? Oh, I did it on the wrong file. There we go. Okay, so now we've got all the people. So the next step is to... So we want to prepare this file, this here. Okay. So I guess... Oh, the paste commands. Okay. That's a new one. So write lines consisting of the sequentially corresponding lines from each file, separated by tabs to standard output. Okay. So we're going to paste. Oh, okay. Interesting. So I guess we could do this, and then we can do a pipe cut on the delimiter here, and then The field we want is the second field. There we go. We got the finance, all that good stuff. But that's not the first name. So actually, we want to get the first name first. So, oh, okay. So we can do the same. But the thing is, if I do it like this, yeah, we got all this extra information. So we got to do another cut. Dash D. There we go. Field 1, 2, 3, 4, 5. Okay, and then we need to do yet another cut. On the space delimiter, which we might need a escape key to do. I will see. Yes. So we need the backslash. There we go. That escapes out that space. So we're searching for a space. We need a special character to do that. So that's field 1. There's the last name, and then we need to use a whole different one for the finance, but we already had that. I forget where it was. Yeah, here it is. There we go. And there we go. So we got it in the other order. We've got the position completely out of order. So I'll put it in order. So we've got the first names, we've got the last names, and then we've got the position, which is yeah, this one. Okay, so we did it with the SCD and the cut. So now let's use the paste. So let's echo. Okay, so we're gonna echo. I am so confused for how to use paste. So write lines consisting of from each file. Okay, each file. Interesting. No file. Read the standard output. Okay, read the standard output. Okay, so I guess we can do so it's paste and then you paste from the file. So it'd be like paste from the file? That makes no sense. So let's do pipe paste and then names.csv. Does that make sense? No, I have to create it. Try creating it. Okay. Oh, it didn't do anything. Okay, well, how do I make it so that it works? Let me try this. Paste names.csv. No such file. Touch names.csv. Paste names.csv. Okay, cat names.csv. So echo test. Pipe paste names.csv. Names. No, nothing. Okay. What about paste names.pipe echo test? Okay, so cat names. Still nothing. Yeah, I don't know how that paste works. I mean, I got the output. The output is here. First names, last names, and then the departments. But I don't know how to what if I do this? Paste dash help and then I do paste dash D comma, and then pipe Does that make sense? That seems to kind of make sense in a way. I feel like this does make sense. Okay, well, I'll paste them all in now. That wasn't it. And I don't even have the file. I need to be pasting them into the file. All right, well, I give up. We're at the, what are we at, the 45-minute mark? I don't know how long the other ones are going to take. So let's see. So, okay, so start with the SED and cut commands. Oh, okay. Well, you know what? I know how to do it now. I didn't know that you could like create. I didn't know like what exactly, because you know, as I said, like you can do it in multiple ways in Linux. So like I don't know like what is fair game and what is not. Like I can just make extra files. They're okay with that. Okay, so this is basically what I did. I did it in a different way. You know what? Let's do it. Well, oh, and of course that didn't work. I must have done something wrong. F1 dash D. Everything looks right. I feel like they did it wrong. Okay, let's just go back to what I was doing for it. So here we go. This is not the first names, so not here we go. All right, here we go. This is the first name, so we're gonna redirect that output to the first names file. All right, and then we'll do the last names file. All right, and then so we have the first name with the first names of the employees. Now we have the file last name containing the surnames of each employee. Next, we determine which department each. Yep. Now we need the department, which I had up before. There we go. Into department. There we go. So now we can do, before we work on the final solution, try the following commands to see what kind of output they generate. So let's try cat, first name, last name, department. Oops. Oh, I called it DEPART. What? Oh, what did I call last name? Oh, last names. Okay, so let's now you can rename a file using the mv command. It's kind of counterintuitive what it actually is, but it should work now. that I rename that file? Yes, it does. I don't see... wait. Oh. Where are the... Oh, it's because I did the same thing with the first names. So MV first names, first name. Okay, there we go. Boom. Okay, now I got everything. So, and then paste, and the final solution, TR. What the heck? Where did that come from? They're just going to introduce some new random concept in a question. That's not good. Okay, so we did the cat. Everything looks good. Let's do the paste. First name, last name, department. Okay, so now we got them more in a format that looks good. Let's try it with a delimitator. Ooh, there we go. That looks really good. Why are they introducing this random thing? Okay, no, they're going to there. So okay, so now for the final solution, which they have to be kind of strange. My final solution would look like this: names.csv, and then a cat out names.csv. Looks good to me. I don't see what's wrong with that, but here's their final solution: past first name, last name, department, pipe TR, which I'm learning about for the first time. TR stands for translate, so we're going to translate that into a comma. Boom. And then we're going to pipe that out to a file. Let's call it names2. Okay, let's type out names2 and names, just the regular names. There we go. So same answer, multiple ways to do things in Linux. So this is kind of like the match function in Python. So here we use the command tr to translate \t, the tab separator, by a colon. So here's something that's kind of cool too. It's like, how do you know that the tab the tab that's matching on tab, how do you know it's not just spaces? Well, here's how. od octal dump to -c on these files. Okay. Wait a minute. Oh, on this? Oh, yeah. So it would be this. It would be yeah, so I think I understand. So it's going to be cat, right? Oh no, paste. So pasting these, pipe od-c. Boom. And so how do we know that they're tabs? Well, because we're inspecting the file closer and we see the \t character. There actually are new line characters as well. Yep, at the end of there. So this is the power of what we learned earlier. So we use the paste command here once we needed to get you familiar with it. Oh, wait, TR is quite useful when we need to exchange one character for another. Be sure to review the man pages for both TR and paste. For example, we can use the -d option for the delimitator to make the previous command less complex, which is the answer I came up with initially. I don't know why they didn't come up with that initially. because they wanted to introduce translate, which is useful. You know, it's dot replace in Python. That's very useful. So we used the paste command here once we needed to get you familiar with it. However, we could have easily performed all of the tasks in a single command chain. And that is basically what I did, but I didn't... Oh, really? All of the tasks in a single command chain? How the heck could we have done that? Okay. Well, I mean, I don't think they're lying, but let's try it out. So I'm going to remove names. You know what? I'm just going to call it names3. So it's sed-n/main office p my password pipe cut -d -f5 cut -d f1 comma 2 pipe tr boom boom, or sorry, boom boom to boom, and then names3 .csv, and then we cat names 3.csv, and wow, okay, so let me think about why this works. Okay, so because we're doing the sed and we're matching on main office, we get all of the 7 entries, and then we cut for the delimiter and take that, and then we cut a second time. Oh yeah, because we're taking out the fields. But we should only have 2 fields, right? This field and that field. Oh, we're using a special syntax here, so we get multiple. Yeah, you can get multiple fields if you use this syntax here. Okay, that makes sense. All right, on to the not even halfway done. Oh my god, this is such a nightmare lesson. All right, so next question, which is not even halfway through the questions. Or actually, it is more than halfway through. Okay, good. So I kind of need a break. So anyway, yeah, I'm going to take a quick break. All right, I'm back. Let's close this out. We're at almost at the 1 hour mark. That's definitely a fair amount of time to spend on these. So suppose that the names.csv spreadsheet created in the previous exercise is an important file. We want to make sure nobody will tamper with it from the moment we send it to someone and the moment our recipient receives it. How can we ensure the integrity of this file using md5 sum? So this is the names.csv file, so we'll cat out that file. All right, and then we'll do md5 sum on it on names.csv. All right, so there's the md5 sum. So let's take a look at the options. So we have this -c here for check. So read md5 sums from files and check them. So C, we've got to pass it a file. So let's do so let's gonna do this. We're gonna do ls, and we're gonna have 2 files. Now we're gonna have this names.csv, and then we'll have we're gonna do md5 sum here that we did before, and then we're gonna redirect the output to names.csv.md5 sum. Okay, and then what we can do is this md5 sum -c names.csv.md5 sum. Oh, and I spelled it wrong. Okay, and we can see it's okay. So that's the answer. Let's see what the official answer is. All right, so if you look at the man pages for MD5 sum, SHA-256 sum, and SHA-512 sum, you will see that they all start with the following text: compute and check XXX message digest, where XXX is the algorithm that will be used to create this digest message. When we use MD5 sum as an example, and later you can try with other commands, so we will use it, and that's what I did. I took a look at the sum. Now, for instance, you can make the file available through a secure FTP service and send the generated message digest using another secure means of communication. So you can send two files. You can send the file that contains all the data that will be used, and then you can send a special file that has the MD5 of the file before you sent it. If the file has been slightly modified, the message digest will be completely different. So then to prove it, that it got corrupt during transfer, so just to prove it, edit names.csv and change the name Jones to James. Yeah, you know what? We can do that. Let's do that. So we're gonna do and we can do that with the sed -I means in place. Yeah, and we can make a backup file automatically out of it. So here we go. We're gonna swap Jones to James for names.csv. We'll make that change to names.csv, and then we'll automatically create a backup file in doing that. All right, and now let's look at the MD5 of names.csv. There it is, and let's see if it passes the check now. Oh, failed. It did not match just because we changed it from James to Jones here. Whenever you make files available for download, it is always a good practice to also distribute a message digest correspondent, so people who download your file can produce a new message digest and check against the original. If you browse through kernel.org, you will find SHA-256 checksums.asc, where you can obtain the SHA-256 checksum for all files available for download. I think that's typically overkill. Like, it was probably really useful when the internet wasn't as reliable as it is now, but I feel like the internet is reliable enough where, like, yeah, that's probably useful in some cases, but in edge cases, most of the time, it's probably not going to get corrupted during transfer. I mean, like, if you're doing like a coding project and like you're worried that people will like mess with your code and like blame you for it not working, you can do an MD5 on your coding project, and then if anyone comes to you and says, hey, your code bricked this stuff, you can say, well, it's not my code. The MD5 doesn't match on the files, and you know, if the code, yeah, so you can write your code so that it like produces, so that it's all in one directory, and then all of its output goes to a different directory, and then the initial directory where it's in has a MD5, nothing changes in it. All the changes or all the outputs to the code happen in a separate directory. All the inputs to the code are also happen in a separate directory. So the directory that the code is in has a consistent MD5 hash, because you can hash a directory as well, I think. Let's try it. So we're going to do ls, or we're going to do pwd, we're going to do backslash to it there, and then we'll do MD5 sum gposh. Nope, it's a directory. Is there any way to hash a directory? That would be nice. Hash Hash a directory. You can't hash a directory. Okay. All right. Well, as I said, I tell lies on this channel sometimes. So I guess the pre-stating statement is I guess the following statement is true, but the prior statement is false. There you go. All right. So on to the next one. I'm going to take another quick break. All right, I'm back. So you promised yourself that you would read a classic book, 100 lines, pages usually, but in this case, 100 lines. So if one line has a word wrap and the sentence finishes on the next line, the 101st line, you would read half of the sentence. So you promised yourself that you would read a classic book 100 lines per day, and you decided to start with Mariner and Mystic by Herman Melville. Devise a command using split that will separate this book into sections of 100 lines each in order to get the book in plain text format. Search for it here. All right, so let's search for it. We're going to do Mariner and Mystic. Free. Oh, I hadn't heard about this site. This is cool. This is a cool site. I really like this site. How do I search for books? Okay. And you just can get it? That's it? Damn. You just get it. That's amazing. Okay, so I think we can do a wget to get it. So let's try that. So go to my home directory, go to, yep, and then do wget help. So like webgit is what that stands for. And let's look at the usage. How do we make that work? Wget option URL. We don't really need. Oh, let's do this. Let's do -o for output file. So we'll do wget -o, and then the output file will be named Herman and Mystic, or Mariner and Mystic, or let's say a classic book. Okay, and then feed it the URL to the text. And we should have the classic book now. We do. Oh, wait, do we? Oh, you know what? That just... Okay. Okay, no, the book is here. The output file is for the wget statistics. Okay, so let's rename this to classic book. Book.txt. Okay. There we go. Now I got it. So now we want to do you promised yourself that you would read a classic book 100 lines per day, and you started to start with Mariner and Mystic. Devise a command using split that will separate this book into sections of 100 lines each. In order to get the book in plain text, go here. So we got to use split. SPLIT help. So you do split, then you do a file. So I think we're definitely gonna want to split it on. Well, let's first inspect that file. See what kind of characters we got. So we got these -r-ns. So this is like the new line character. So we'll be matching on that. So split lines, split dash L, invalid number of lines. So lines 100. Did it split it into 100 lines? What happened? Ooh, that's bad. Oh, okay. Well, you know what? It did it. It split it into 100 lines. So it looks like it has its own syntax. So like X is like means that the file's been split, and then AB is the ordering of the file. So if we wanted to read the first 100 lines, we go like this, and we can read the first 100 lines, which is kind of awesome. And then to read the next 100 lines, we go like this. This is cool. This is like really cool, because like what you can do is you can set it up to give you 100 lines like every time you log in. So like every time you log in and use this, you know, you can have it print out 10 lines, but like 100 lines in a book, and it's like, that's cool. I really like that. I really like that. I feel like I'm going to do more reading, like now that I know. And then it goes all the way to Z, and then now it's at Z, it's BA. All right, so that's my answer, and I'm sticking to it. Split it into, so yep, it's pretty straightforward. So so first we will get the whole book from the Project Gutenberg site, where you can get this and other books that are available in the public domain, which is awesome. So wget there. You might need to install wget if it is not already installed in your system. Alternately, you could use curl, use less to verify the book. Did that. Now we will split the book into chunks of 100 lines each. So now they did some extra things that I didn't do. They used -D as well. So let's take a look at what I did. So I did just -L. I did not do the -D. Let's see what the -D does. Oh, you know what? The -D probably puts it in its own directory. Wait, what? Use numeric suffixes starting at 0, not alphabetic. Okay. All right, so that's what they did. They used the -D and then. Okay, so .txt is the file we will be splitting. Melville will be the prefix for the split files. The -L100 specifies the number of lines, and the -D option tells split to number the files using the provided suffix. Okay, that makes sense. You can use NL on any of the specified on any of the splitted files, probably not on the last one, and confirm that each have 100 lines. Let's do that on mine. So, LN is so LN. Let's do ZZ. Does it have that? No. Okay, let's do CA. It doesn't have that either. Okay, let's do BB. Doesn't have that either. Okay. How about cat BB pipe LN? Or LNBB? What? Oh, I'm using the wrong syntax. So LMXBB. File exists. Okay. Oh, LN, or what did they tell me to use? NL. Okay, I was right. NLXBB. And there we go. The nines are numbered, and the last line is 100. So I'm going to clean this up. You can do that. So let's do LSX like this and see if we have any extra files. Okay, no, those are all the files. So I'm going to do RM X star, and that'll clean up all those files. So now let's do what they have here to see how the naming changes. And I did rename the file, so let's name it back to 50461 .txt Melville. It's not a directory. Oh, yeah, okay. There we go. Perfect. All right. So split -L 100-D 504 61-0.txt Melville. There we go. And let's see what that naming looks like. Now that's a lot clearer. Except we do have this. Once it gets to, oh, you know what? That's because it's using. So it's still, even though it's not saying like AAAB, you know, it's still using the same, like it's using, I don't know. Well, it's weird. I don't know what's going on here, actually. It's weird. I prefer the AB personally. But I think what's going on is, like, here, like, you would have to start using B instead of A before. Let me read a little bit from this. This book sounds like it could be interesting. So, the benefits of the true faith were not to advance into the Pacific unassisted by the secular arm. 2 officers of the French Navy, in their considerations, I don't know. This kind of doesn't sound that interesting to me. All right, so split it into. I like sci-fi, fantasy, those sorts of things. Okay, on to the next one. Okay, so number 6, using ls-l on the etc directory. What kind? Sorry, my okay, that just happens sometimes. My headphones just randomly start beeping at full volume sometimes, and it's very startling. All right, so using ls-l on the /etc directory, what kind of listing do you get? All right, so let's see what kind of listing I get. ls-l etc. I get lots of listings, all sorts of things. Using the cut command in the output of the given ls command, how would you display only file names? All right, so the file names are at the end here. So one thing we could do is pipe cut with a delimiter of a space, and then we can take the last field, so we can do this special character, and I guess that didn't work. I thought that was how that worked. Okay. I really thought that was how it worked. Okay. I need to change my posture here quick. All right, well, it's fine. We can just count out the fields. So let's, okay, there we go. All right, so we can just count out the fields. So or experiment around. Let's just experiment. So let's try it with 6. All right, that didn't work. How about 5? All right, so 5 gives us root, which is here. So we need quite a bit more than that. Let's try it with 15. Okay, 16, 17. There we go. So we've got the, right? Are those the file names? I'm confused. Well, I mean, it's the last one, so let's try 18 and 19 and 20. Okay. I'm not sure if I'm doing this the right way. Okay, well, that doesn't seem to work. How would you display only the file names? I mean, I thought you would use the command like that. So, I mean, you would do it like this, and then, I mean, you would cut based on a delimiter, and I wanted to cut based on a single space, but that's difficult because there's like a lot of spaces there. If I could just cut the last, so if I could do like the delimiter being a space like that, and then the field like the last field like that, but I don't remember. I don't remember how to feed it a character to specify the last. I thought there was a way to do that. Okay, so -F, unless the -F. Okay. So you can feed it a list. Oh, here we go. So nth character is counted from 1 to the end of the line. From the nth to the nth. The first line. Can I do it backwards? No, I don't think I can. Okay. By commas, okay. So I could do it from, man. You know what I could do? Because these are, like, it's consistent. It's designed so that this is consistently that character. So like I can do a cut pipe. So like cut help, and I could figure out like which or like trim is that one. No. Oh my god. Oh, I'm really confused how I can do this. So ls-l etc pipe cut, and then what can I do? What can I do? I can do it on the nth character. So let me try that. So 10. Oh, I must specify a list of bytes characters. What about dash b 10 dash b 20, or wait, dash t. Okay, 2. Okay, this is what I'm looking for. So I want to look 10, comma 15. Yeah, like that. And then I want this to be pinpointed. So let's do this. Let's go back to this. Okay, and then we're gonna do echo up to here. Okay, pipe WC. Okay, and now we can see it's 50 long. So okay, so we're gonna do 50, and then that will go to the end of the line. Character bits are numbered from 1. 50 dash. Yeah, okay, there we go. Got it. So 50 dash, that if I do 49, then I get that space in there. Or not. If I do 48, then I get that space in there. Yeah, there we go. So we got to start from 49. Perfect. Okay, I got it. So using the ls-l, what kind of listing do we get? How do you display only the file names? We do it like this. All right, what about the file name and the owner of the files? So I guess what we could do is redirect this output here to file names. Okay, and now we can do it for the owner of the file. So let's do ls-l. There we go, and the owner is here. The group is there. So we can do the same thing where we do a echo like that. Pipe WC. Last character is 14. So we'd start on 13, I believe. Okay. You know what we can do? We can do 13 like that. Or it would actually, I think, need to be 15. Yeah, like that. And then we can do a cut the delimiter space the first field. There we go. We can do that and then pipe it to owners. All right, and now we can paste with a delimiter of comma the owners and the file names. There we go. All right, so there we go. Along with ls-l and cut commands, utilize the tr command to squeeze multiple occurrences of a space into a single space to aid in formatting the output with a cut command. Oh, I guess we could have done that as well. So /help. We can do squeeze repeats -s. So we can do it like this. ls-l There we go. Pipe TR dash S for and then what we want to do with TR dash S squeeze repeats. So replace each sequence of a repeated character, which is listed in the last specified set with a single occurrence of that character. Okay, so we'll have repeated spaces. There we go. And then now we can do cut on the space delimiter, and we can just pick out whatever fields we want. There we go. So now it's really nice and clean since we have all the spaces now are squeezed together. So really, really nice and clean. So it would be the last field. There we go. There's no 10th field as far as I know. Or there's for symlinks there is, but perfect. Okay, so utilize TR to squeeze multiple occurrences of a space into a single space to aid in formatting the output with a cut command. Let's see what the official answer is. So the ls command by itself will give you just the names of the files. However, we can, prepare the output of the ls-l, the long listing, to extract more specific information. So we can use this quotes instead of the way I did it, which is escape character and then just the space. It's probably a little cleaner to put it that way. And then, separate. So they created their own delimiter as well. I did not replace the delimiter. I just squeezed together all those characters and then used the space as the delimiter. This is probably a better way to do it. The -s parameter instructs TR to shrink the repeated spaces into a single instance of a space. The TR command works for any kind of repeating character you specify. Then we replace the spaces with a comma. We actually do not need to replace the spaces in our example, so we will just omit the comma. Okay, so they did do what I ended up doing. If you want just the file names, then all we need to display is the 9th field. Perfect, saw that. For the file name and owner of a file, we will need the 9th and the 3rd fields. Okay, and this is perhaps where I went wrong. They were asking for them to be displayed, like this, and I didn't come to the conclusion to pass a list into the -f option. So I kind of got this wrong on that regard. What if we just need the folder names and its owner? So we would do this. Let's just paste that in. You know what? Let's type it out just because. Sometimes getting it in the fingers is a better way to remember it. ls-l etc grep. Okay, and we're grepping for a line that begins with D, so that we know that it's a folder, and then we're gonna translate and squash all the spaces down so there are no duplicate spaces, and then we're gonna cut based on the delimiter, which is the space, and then we're looking for fields 9 and 3. All right. Okay, so next exercise, and I'll take a break for that. It's the final exercise, thank goodness. We're at the 1:30 mark, so this might be the longest video so far in the series, but I'll take a break and I'll come back and finish it out. All right, I'm going to do it. I'm going to close this out. Oh my Lord, this was I'm watching the goat of online fitness content, but I'm gonna finish this up. So this exercise assumes you are on a real machine, not a virtual machine. I'm on a virtual machine. You know what? and I don't care. Oh, you know what? I am on a virtual machine. Also, you have a USB stick with you. Review the manual pages for the tail command and find out how to follow a file as text is appended to it. I know how to do this. I used to do that at work all the time. While monitoring the output of a tail command on the /var/log/syslog file, insert a USB stick right out to the full command that you would use to get the product, manufacturer, and total amount of memory on your USB stick. Okay, so if we do a tail -- help, we have this option -f, which is follow. So output appended data as the file grows. So let's do tail -f var log syslog. There we go, and we can see we printed out, but we didn't exit. We're still sitting here on the system. So I'm just gonna keep this running and go and plug a flash drive into my system. Should not take me long, and then we should see some messages show up there. And there we go. We got all sorts of messages, and they all have to do with a new device being found. So next part of the question. So write out the full command that you would use to get the product, manufacturer, and total amount of the memory stick of your USB. So let's stop that here. So we're looking for the product, manufacturer. So here we go, product 2. Manufacturer Sony. And then the size, right? Total amount of memory. So total amount of memory, I don't see that. Maybe this? I guess this is the total amount of memory. Okay. I think I'm gonna go with that. So so we can do on the var syslog, we can do a sed-n, and then we're going to search for product equals. We're gonna print that out. Oh, and we gotta feed it the file. Var syslog. Oh, var log. Wait, what? Syslog. There you go. So we've got it from the timestamp. So here's ID product, and then there's product equals 2. I don't know. New device found. Write out the full command you would use to get the product, manufacturer, and total amount. So here's the command you would use to get the product, I think. And we can use a space. We have to escape the space. There we go. And now we get the product. Do a pipe cut on the space for the delimiter. Okay. And then the field is like guess a little bit. So that gives, it's just gonna be more than that. More than that as well. Oh, you know what we can do, which will be better? sed-n / escape product equal, okay, p, and then / var log syslog pipe tr for translate, and dash s for squish. Wait, does that make sense? No, let's do this. Let's translate spaces into nothing. Oh, string must be non-empty. Okay. Well, so much for that. Let's translate the comma space into just a comma. There we go. And then we'll do a cut using the comma delimiter. Okay, and then we'll do a field this way. USB. Okay, 15. There we go. So now we've got it. It's at field 15. Product equals 2. All right, and then the command we would get to get that, it's just more of the same. I think I got the point. The manufacturer is oh, you know what? Here's probably what they were looking for. Yeah. This is what they were looking for sure. All right, so let's search for that. So we'll match it on product colon space. Yeah. Okay. All right, and now we can do a cut on the delimiter here. Field. So we got 1, 2, 3. Home lab kernel. Oh, okay. Actually, we've got more fields than that. There we go. Oh, but no, we can't. We can't have the delimiter be that. I guess we could have it be 1 colon, and then a single character. Well, that's not good, because I need to get that whole thing. You know what? I just want to close this out. We're at the 1:45 minute mark. That's a lot. So let's see what the official answer is. All right. So okay. So here's their answer. Type that in. Okay. Clear tail -f. Oh, this is kind of cool. So log. So you can pipe this. Oh, of course, grep. Dang it. See, I thought they wanted you to case insensitive. Escaping this character, escaping pipe character. I wouldn't have ever gotten this.
Okay, so this is the line that we get. So I think I have some more. I'll unplug it and plug a different one in. I think I can do that. So I'll try to do that really quick. If I can't do it, I'll come back and say I can't do it. All right, I can't do it from multiple, so I just plugged the same one. Well, you can see what I did. I unplugged it and then plugged it back in. Then I plugged it into a different port, which we see specified there. So, of course, this is an example, and the results may vary depending on your USB memory stick manufacturer. Notice how we use the -i parameter with the grep command, as we are not sure if the strings we are searching for were in upper or lower case. We also used the pipe as a logical OR, so we search for lines containing product or blocks or manufacturer. So look at that one more time. So we're searching for product. Now this is interesting that the logical OR is escaped. Let's try it without escaping the logical OR. Okay, so we don't find anything if we don't escape the logical OR. So in order for it to be a logical OR, I guess it's got to be escaped. That's interesting. All right, so now we're on to the summary. So dealing with text streams is of great importance when administering any Linux system. Text streams can be processed using scripts to automate daily tasks or finding relevant debugging information in log files. Here's a short summary of the commands we covered in this lesson. Cat, used to combine or concatenate or read plain text files. bzcat allows for the processing or reading of files compressed using the bzip2 method. xzcat allows for the processing or reading of files compressed using the xz method. zcat allows for the processing or reading of files compressed using the gzip method. Less, this command paginates the contents of a file and allows for navigation and search functionality. Head, this command will display the first 10 lines of a file by default. With the use of the -n switch, fewer or more lines can be displayed. Tail, this command will display the last 10 lines of a file by default. With the use of the -n switch, fewer or more lines can be displayed. The -f option is used to follow the output of a text file that has new data being written to it. WC, short for word count, but depending on the parameters you use, it will count characters, words, and lines. Sort, used for organizing the output of a listing alphabetically, reverse alphabetically, or in a random order. Unique, used to list and count matching strings. OD, the octal dump command, is used to display a binary file in either octal, decimal, or hexadecimal notation. NL, the number line command, will display the number of lines in a file as well as recreate a file with each line prepended by its line number. Sed, the stream editor, can be used to find matching occurrences of strings using regular expressions, as well as editing files using predefined patterns, which seems kind of similar to grep to me. TR, the translate command, can replace characters and also removes and compresses repeating characters. Cut, this command can print columns of text files as fields based on a file's character delimiter. Paste, join files in columns based on the usage of field separators. Split, this command can split larger files into smaller ones depending on the criteria set by the command's options. MD5 sum, used for calculating the MD5 hash of a file, also used to verify a file against an existing hash value to ensure a file's integrity. SHA-256 sum, used for calculating the SHA-256 hash value of a file, also used to verify a file against an existing hash value to ensure a file's integrity. SHA-512 sum, used for calculating the SHA-512 hash value of a file, also used to verify a file against an existing hash value to ensure a file's integrity. And I finally finished this nightmare section. Took like 6 parts, the last part lasting 2 hours almost. How long? Yeah, nearly 2 hours. So stay tuned for the next one, which hopefully is not as much of a nightmare. So thanks for watching, and stay tuned for the next video.